And that is why slope fields are probably the most important thing you will ever learn in your life. Now, for our next subject in calculus, trapezoidal rule.
So pretty much the entire class has become sick of calculus right now.
We've been talking about slope fields for over a month, which is pretty redundant considering the variety of content we need to know before the exam.
The AP exams are a few days away, and the class is pretty much withering with every word Mr. Goldstein says.
Essentially, if we don't learn what we need to before the AP exam, best case scenario, probably a 3, which wouldn't be that bad, I guess.
Alright, so I assume everybody remembers the formula for the area of a trapezoid?
Ladies and gentlemen of the 2018 to 2019 calculus class, for too long we have toiled under the tyranny, the iron fist, the iron protractor of Alan Goldstein. It is time for a revolution.
Raise your voices. We need a revolution. Volumes of revolution.
We're positive that the class will be into it. We all feel the same pressure and stress, so why wouldn't they be? Volumes of revolution. Volumes of revolution. Volumes of revolution.
Guys, I don't think it's that big of a deal. We all need a refresher on trapezoidal sums anyways.
No. This is not what we need. For too long, we have listened to nothing but slope fields and trapezoidal rule for the last semester. I mean, you guys have been lost in the slope field of broken dreams. I mean, we need a change in what we're learning.
We need volumes of revolution. I think we're losing them.
Okay, we got this.
Well, if you really want to talk about volumes of revolution...
Whoa, no.
But I can teach you.
No.
But I know how to...
No. Listen, man, I'll teach you. I got this one.
Wait, if you already know this, why are you freaking out?
Yeah, Halima, I thought you didn't know this yet.
Well, why wouldn't I be teaching it?
I've always known Halima to be a bit of an intense student when it comes to her work, but at this point, man, I just work here.
Halima, I really don't think this is necessary. It's probably just a small topic.
Maryam, haven't you noticed Mr. Goldstein's been teaching us the same thing over and over again all year?
Yes. This is literally blunt force trauma by calculus, okay? I'm gonna show you something even better, okay? You'll see. So there are a few scenarios to find the volume of a revolution. You can have it revolve around a horizontal axis or a vertical axis, but you can also rotate it between two curves. And oftentimes you will have to account for a disk or a washer.
A disk is basically a circular cross-section of a graph rotation, whereas a washer is a circular cross-section with a space in the middle. Sometimes when you rotate around a certain point, it leaves a respective distance in the rotation, which is something to account for.
Wait, but what does this have to do with calculus?
I'm glad you asked, Richard.
My name is Riley.
I'm pretty sure you said it was Richard.
We've literally known each other for 3 years now.
Riley?
Yes, Halima. You didn't know? Wow, you actually do learn something new every day in calculus.
So back to your question, my fellow student. Basically, when doing problems like these, we utilize integration through the disk formula, which is, and when we have to account for a washer, we do. So let's try a problem. Let's say we have to find the volume of the solid formed between y equals 9 minus x squared and y equals 12 for 0, 3. But we have to revolve the solid about y equals 12.
So as you can see, the rotation about y equals 12 will give us a disk with the radius of big R. To find big R, we would have to subtract f of x from 12, which gives us 3 plus x squared. So now, using the disk formula, we square the equation and integrate it with FTC. Oh, and also multiply by pi to get 648 pi over 5.
Wait, so how do you do it with a washer then?
Yeah, we can try it with a washer. Let's say we rotate it around y equals 15. Because we are rotating the space between f of x and y equals 12, it will give us a radius with the distance of 3 from y equals 15. This means that when we use the disk method, we are going to have to account for the extra space.
So then to find big R, we would do 15 minus 9 minus x squared, which would give us 6 plus x squared. And we already know that our other radius, little r, is 3. So we square both equations, subtract, integrate with FTC, and then multiply by pi.
Which gives us 1,188 pi over 5.
Alright, so that's fine, but sometimes you'll have to do a rotation around a vertical axis rather than a horizontal axis. When this happens, the process is essentially the same, you just have to flip around the variables that you're using. Take this problem, where we have to find the volume of the solid obtained when we rotate the region enclosed by the graph of x equals square root y and x equals 0, from 1 to 4 on the y-axis.
Just treat the y-axis as if it was a horizontal axis in another problem. This will make it easier to wrap our minds around it. We'll only have an outer radius, which will be x equals the square root of y. So we take the integral of the square root of y squared dy and multiply that by pi, which gives us 15 over 2 pi.
I mean, yeah, that's pretty much it.
You're welcome.
Like I said, intense.
I think we did a pretty good job. Now we just need to teach them the rest of the course.